Welcome you all. In this session we are going to discuss in detail about the designing of core in transformer. For transformer, the core cross section may be rectangular, square or stepped. When circular coils are required for distribution in power transformers, the square and stepped are used. So usually in distribution transformer circular coils are used, whereas in power transformer the square and stepped type cores are used. For shell type transformer the cross section may be rectangular. When the rectangular cores are used, the coils are also rectangular in shape. The rectangular core is suitable for small and low voltage transformers. For higher rating we usually go for stepped type core. In core type transformer, the rectangular cores, the ratio of depth to width of the core is 1.4 to 2. In shell type transformer, the rectangular core with width of central limb is 2 to 3 times the depth of core. So the following figure shows the cross-sectional view of transformer cores. So here, as I told, there are three types. They are rectangular, square or stepped type, or stepped or otherwise called as a multi-core. You can also call it as multi-core. So the circle we usually name it as circumferencing circle. Usually while solving problem, most of the time with the help of this diameter we used to get the data, we used to attend the data for core design. So in square cores, the diameter of circumferencing circle is larger than the diameter of stepped core. So if you compare the circumferencing circle, so that for square type will be larger than that of the stepped type. Thus, when stepped cores are used, the mean length of winding is reduced, with consequent reduction in both cost as well as copper loss can be reduced. If the copper is reduced, automatically copper loss. In addition to this, the cost can be also reduced. However, with large number of steps, a large number of different size of laminations have been used. The result in higher labor charge for sharing and assembling the different types of laminations. Square core. So let d be the diameter of the circumferencing circle and small d the diagonal of square. See, the diameter is equal to the diagonal of square, isn't it? So let a be the side of square. Let a be the side of square. So the diameter of circumferencing circle d is equal to, so by Pythagoras theorem, d is equal to square root of a square plus a square. It is root 2a. So d is equal to root 2a. So with the help of this relation, either if you know the diameter of circumferencing circle, the square side can be attained, or if the side of square core is known, then the diameter can be calculated. So therefore the side of square A is equal to d by root 2. Gross core area is given by AGI, which is equal to A square, which is equal to 0.5 times of d square, which is equal to 0.5 times of d square. Just I have substituted the value of d by root 2 in case of A. So I'm getting a value of 0.5 d square. We know that the stacking factor for transformer is 0.9. So the net area is nothing but stacking factor into gross area. So the stacking factor value is 0.9 multiplied with the a square value. So already we found that a square is equal to 0.5 d square. So while substituting, I am getting a value of 0.45 d square for net core area. So the gross core area is 0.5 d square, whereas the net core area is 0.45 d square. So the area of circumferencing circle is usually the area formula is pi r square. Here r is unknown, so I am replacing r by d by 2 the whole square. It becomes pi by 4 d square. So the ratio of net core area by the area of circumferencing circle is 0.58, and the ratio of gross core area to the area of circumferencing circle is 0.64 for square type core. Another useful ratio for designing transformer core is net core area divided by square of circumferencing circle, which is equal to 0.45. So next we are going to discuss about two-stepped core for core of transformers. In stepped core, the dimensions of steps should be chosen such as occupy the maximum area within the circle. The dimensions of two steps given maximum area of core is given by, let A be the length of rectangle and B be the breadth of that rectangle and D be the circumferencing circle. Theta be the angle made between the diagonal and length of rectangle. See here you can see. So this is the circumferencing circle. So it's a two-stepped. So this is a first step and second step. And D be the diameter as well as the diagonal of the rectangle. Diagonal of rectangle and the diameter of the circle both are one and the same, which is denoted by D. B be the breadth and A be the length. So now, while calculating the ratio of net core area to area of circumferencing circle is 0.71 and the ratio of gross area to area of circumferencing circle is 0.79, and another useful relation, that is net core area by square of circumferencing circle, which is 0.56. So here I have compared the various ratios for square core, circular core as well as 3-stepped and 4-stepped core. So this comparison chart is used for designing parameters. We can prove that the area of circumferencing circle is most effectively utilized for the stepped core. So by increasing the stepped core, you can see the ratio get increased. So for all other cases, square it is 0.6. So while you compare it with 4-stepped core, it is 0.87. So it is an increasing order. So by increasing the number of steps, you can increase the effectively you can use the core area. The most economical dimension of various steps for multi-stepped core can be calculated by using this table. Thank you.